Welcome back to another proving episode where I show you why things are the way they are. For in this case, with deriving, well, not with deriving, but from the previous video, I showed you why sine, when you derive it, it equals cos, and it was this that come up along the way, sine h, or the change in x, over h, the change in x. It can be also, you can see it sometimes as y equals 1. And you can sometimes see in textbooks or whatnot how it'll have sine theta over theta equals 1. And I'm basically going to show you that today. So, h is an angle. Here we have h, our angle. We have three triangles. We have the first triangle here, and it looks a bit like this. Oh, no, we don't have three triangles. We have a couple of shapes. Put it that way. So that one there, that line down the middle, is just what we will be calling the height. You see how that's there. And then we also have another shape, just a little bit bigger than that. And it looks the exact same, except it follows the unit circle around. See that little gap there? That's because this is a little bit bigger than this. And then we have our third shape, which is the big triangle. It sticks right out here. Okay, so basically we're going to find the three areas of this and write down that this one's smaller than this one and this one's smaller than this one, and eventually work it out so we get that. Now that's what I'm going to do. So we'll start with this small circle here. Grab another page, see if we can fit it in. Okay, so we'll start by finding the height of this triangle. So we've got the triangle. We want to find the height. So we'll use the first triangle. Turn it into a right angle. Our angle is h. The radius, I don't know if you can see it here, but the radius is 1. It's 1 because it's a unit circle. And the length of this bit here is 1. The big triangle comes right out here, but the small triangle stops at the radius. So it has the hypotenuse on this diagram is 1, and the angle is h. And because we are trying to find the height, when you use trigonometry, you find that it's equal to sine h. That is because sine is equal to opposite over the hypotenuse. That's a terrible h, but opposite over the hypotenuse. So sine h, the opposite we know is sine h, but I'm just going to write opposite for now, over the hypotenuse. If the hypotenuse is 1, then you don't have to write it, because this here is also over 1. If it's there, like sine is over 1, because everything is just about over 1. Anyway, so we can just about cancel these out, and what we're left with is the opposite being sine h, which is what we've got here. So the opposite of the angle is sine h. So the height is sine h. Now what we've got to do is find the area of this triangle, which is this bit here. Therefore, this triangle, I'll just redraw it. We know that the height is sine h, and we know that the base is 1. That's all we need to know, because when we're finding the area, we get half multiplied by the base multiplied by the height. So half multiplied by the base, which is 1, multiplied by the height, which is sine h, which just equals half of sine h. Okay, now that we've established that, the area of this triangle here, or this triangle here, the first triangle, the smallest one, is half sine h. Now for the next one, which isn't not a triangle obviously, but it's a portion of this circle, because we've got the radius. We've got the radius here and a radius here, but then we're following like the unit circle around. That's a very bad circle, obviously. I'm not an artist, I'm a mathematician. Okay, so we're going to find out what this little portion is. Okay? So we're going to start with the area, because that's what we're trying to find. Now, I'll redraw it here. H. We know that has a radius of 1 at those 2 points. I'll rewrite this. The area. We'll first write the area of the circle, which is pi r squared, and we'll multiply that by what we're trying to find, the portion. The portion, when you think of this in terms of radians, we start at 0, we go up to pi over 2, we come down to pi, then we come to 2 pi on 3, and then we come to 2 pi. 2 pi is the equivalent of 360 degrees. So we'll be focusing on radians, because that's just the way it's done. You do it in radians, and I will be doing it in radians. So multiply it by h, which is the angle, over 2 pi, because we're saying h, which is the portion of the whole circle. And now we're going to simplify this a bit. So we've got a pi, we've got a multiplied by a pi and a divided by a pi, so we get rid of them. R squared is just 1 squared, 1 squared is just 1, so it'll be like 1 multiplied by h over 2. I'm just going to write h over 2, because this little section here is equal to 1, so it's just 1 multiplied by h over 2, which is h over 2. Okay, so we've established that this third shape has an area of h over 2. And now, last, we're up for the big triangle. Okay. Big triangle. So we know that the length of the base is 1, because that comes out to the radius. It comes out the full length of the unit circle. And we have our angle h. Now, this here is opposite. And it's actually equal to tan of h. And I'll show you why. Okay. So, we have tan is equal to opposite over adjacent. Tan h is equal to opposite. Now the adjacent is 1. So just like before, it's over 1, both cancel it out. And it's tan h equals the opposite. So the opposite equals tan h. So the height of this triangle is tan h. Now that we know that, we can find the area. Like I said before, the area, half, multiplied by the base, multiplied by the height, And what we're left with is half multiplied by 1, which is the base, multiplied by the height, which is 10h, which equals half 10h. Okay, now that we've got that, I'll rewrite them all under these triangles here. Area for this one equals half sine h. The area for this one, I'll try and divide it a bit. The area for this one is h over 2. And the area for this one is half of tan x. Oh, h, not x. Half of tan h. Now, we know that this is smaller than this, and this is smaller than this. So I'm going to write it as so. I'll grab another sheet of paper and write it a bit bigger. So here we've got sine, half of sine h, and we know that that is smaller than h over 2, and we know that h over 2 is smaller than half of tan h. Okay. What can we do to this? Well, first of all, we can multiply it all by 2 because it's divided by 2. So if we multiply it all by 2, that'll cancel out the 2's. And what we're left with is sine h smaller than h, which is smaller than tan of h. Now what I'm going to do here is divide by sine h. Divide it all by sine h. Okay, I'm going to grab a spare piece of this. I'm going to grab another sheet of paper and show you this bit over here, the tan over sine h. We have tan h divided by sine h. First, we know tan h is equal to sine over cosine, and then when we divide that by sine, we can actually get rid of both of the sines, and we'll have a 1 there. Because we have a sine divided by a cosine divided again by sine, we can get rid of the two sines, and we're left with 1 over cosine of h. And that's what we'll write. So I'll start at this end. 1 over cos h. In the middle, we just have h over sine h. And on this side we have 1, because sine h over sine h is 1. Now you probably will start to notice that, or I don't know if you have, that h over sine h is very similar to sine h over h. So that's what we're going to do. We're going to flip this. And to flip this, we're going to have to flip this, flip that, and turn these greater than signs into less than signs. Or greater than or less, whichever way you're looking at them, we'll flip the arrows so they're facing the other way. Because that's what you do. Because if you were to have something like 1 is smaller than 2, then if you rewrote it, you would have 2 is bigger than 1 if you flipped it. And that's what we're going to do. We're going to flip it. Okay. I'll grab another sheet of paper. So we're going to flip this. That's already 1 over 1. When you flip 1 over 1, you just get 1. Now we're going to flip this sign around. So 1 is greater than sine h on h, which is greater than cosine of h. So what I did was I flipped this, and then I turned the sign around, and then I flipped this, bringing the cosine h on top. Now that we have this, here's where the proving really comes in. Okay, so now we have this, we have 1. If we find the limit as h approaches 0 of 1, we get 1. Because there's no h in this, so we can make h any number we wanted and it wouldn't affect that. We can make h 10, 20, but because there's no h in here, it just becomes a 1. It just ends up being a 1. And the limit as h approaches 0 of cosine of h, well, cosine of 0 is 1, so the closer it gets to 0, it'll be 1. And now, that basically means that the limit as h approaches 0 of sine h over h equals 1. Because if 1 as it approaches 0 is still 1, and if the cosine of h as h approaches 0 is 1, then you've got 1 is greater than sine h over h, which is greater than 1. So you've got 1, 1, therefore 1. And that's why when the limit of h approaches 0, sine h over h is equal to 1. Thanks for watching. I hope this helped.